Hi there. My name is Gautam Adhikari. My project is SmartMassing, an AI-powered semi-automated code compliance and early-stage massing design. I am doing this dissertation as a part of my MSc in computational methods in architecture. The context is in architectural design, code violations are often discovered too late in the design process, and building regulatory codes are very complex and text heavy. And now there's no such compliance system that can actually do compliance during the early stage design phases. So in the literature review, let's talk a little bit about the local context. In Bangladesh, 2D CAD or Rhino is mostly common. BM is comparatively rare. BNBC, the Bangladesh National Building Code, lacks digital integration. So what we need a lightweight and explainable AI compliance tool that will help architects or designers for the early stage building design. For these projects, I have shortlisted 70 pages from the BNBC that's mostly focused on the architectural early stage design. So when I go into the 70 pages, there's mostly three types of questions. One is the definition, the second one is the explanation, and third one is the math. Definitions can be questions like what is a courtyard or what is a loft. Explanation can be why FAR is required. FAR means floor area ratio. And math is some sort of deterministic math, like for a for a 750 square meter plot, what can be the setback? Or what is the maximum amount I can build on a 963 square meter plot? To which questions there's a specific answer. So this is my methodology. On the right hand side, this is the part one. That's my core LLM part. And on the left hand side, the part two is my Rhino+Grasshopper integration. The orange one is the pre-processing, where I get the data from the BNBC text and I made a vector store out of it. The green one and the yellow one is my core landgraph module, where I am making a light LLM chatbot, RAG-based chatbot that can query through analysis, definitions, math, or explanations. And on the bottom, you can see the interface is the first API endpoints, and I'm using a Gradio UI. So there's two parts of this project. One is the simple chatbot that can access definition, explanation, or math. On the left-hand side, there's another part that can connect to the Rhino+Grasshopper geometry. So the system workflow. So there will be actually then four type of queries. The initial one is the chatbot definitions. What is a fire door? If I give this input, I will get an output like a definition of the fire door, something like that. If I use the chatbot explanation route, I will ask it why type of questions, like why your balcony is exempt from the site coverage. And you can see that why questions, like the explanation questions are comparatively a little bit bigger. In the chatbot math route, I am asking math queries like for a 200 square meter plot, what will be the FAR MGC? On the right hand side, you can see the observed output is something like this, that I am getting the FAR, MGC, and max value. That's the very deterministic output. And when I'm using the Rhino+Grasshopper route, I'm just adding a sys prompt in front of the queries. So that actually makes the system to give a strict JSON output. So initially what I will do, I will enable the virtual environment. Then I will run the pre-processing that will make the Chroma database, the vector database, out of my BNBC 70 pages code. After that, I will run the Gradio UI. You can see that on the left-hand side, the BNBC compliance chatbot has started working. So let's try some queries. So I have asked the simple questions like what is a habitable room? And you can see that I am getting an instant answer. Let's ask some more questions. Like I have asked like what is a balcony? You can see that I can see a runtime out of it. It's getting me the definition of balcony. Let's ask a little bit why questions, like why balconies are excellent for site coverage. You can see that it's taking a little bit longer time, the definitions. So yeah, now I'm getting the explanation of a why questions. Let's try math queries, like for a 1400 square meter plot on a 12 meter road, what FAR applies and what are the MGC for it. The previous one took 2.9 seconds. Yeah, we got the queries. So you can see that I'm getting the site area MGC's calculations, I'm getting a reasoning, and in the end, I'm getting a conclusion, like what's the end results out of it. And now I'm trying a sys route. If I put a sys in front of it and ask a queries like this, the same one I have showed you in the previous slide, let's see what happens. You can see that when I have put the sys queries, it's getting instantaneous answer, and it's also getting a compliance failed and also explaining the reason behind it. I am closing this part. I am closing the chatbot. Let's try the Grasshopper Rhino route. I'm initialing the lang of GH that will connect the radio environment that's directly connect to the Grasshopper. Yeah. So the difference between the normal chatbot and the Grasshopper is in the Grasshopper you cannot actually ask any questions in the chatbot. You can just observe the output or previous chat from the website or from the browser. Basically, you have to see things within the Grasshopper. So within the Grasshopper, I have two forms. On the left hand side, you can see there's a building form and there's a plan format. So I have two type of analysis. One is based on the building form, and the other one is based on the plan analysis. In the building form, there's sites, there's building mass and road. And the plan site, there's different plan and room sizes. So you can see when I'm connecting all my geometry, I'm getting an automated query. So for this, I'm getting a query like by analyzing the site, I'm getting a query like for a plot this size, what's the far range or maximum value, and I am asking the system to give a specific output in this format. So let's see what happens if I run this program. Okay, currently the play is false, so I couldn't get any query. So let me play it a little bit back. Initially the play is false, so when I play it true, I instantly get a query out of it that my compliance, this is not a compliance portion, so it's a query type portion, so there is no compliance. Let's check some sort of compliance portion. So I have asked for a query sellback. It's also a query, so I'm getting a query output. There is a query, there's no compliance. So yeah, I am asking the max ground coverage. It's already analyzing my geometry and said that this design is violating the code. So let's see what we can do to do it. Okay, we are trying another one, the total built area. This is also violating my code. So what we are doing on the left hand side, we are deleting some building volumes and see. We are already getting a code compliant volume when I deleted some masses out of it. For example, if we add that volume, you can see that on the right hand side, the code is again violating. So this is a live demonstration that what can be done. Let's check room analysis. If we can check the data or code compliance of a room size. So I am selecting this bedroom and I am trying to see that these two are the fire stairs, and I will try to see that if the room is close enough to the fire stairs or not. So I'm selecting the fire stairs distance. Currently the code is compliant. So let's see if I move this room a little bit far, what happens. You can see the instantly I get a comment that the design is violating the code, because in the explanation the reason is specific that the minimum travel distance is 33 meter, which is supposed to be 23 meter. On the other hand side, I can also remove these fire stairs a little bit far away and check what happens. See, when I remove the fire stairs, the design is again violating. So that means it's a live demonstration or the compliance is working in real time here. So in conclusion, I can say that the contribution of this project is it's developed the SmartMassing, the first AI-powered semi-automated BNBC compliance framework for early-stage massing design. And its impact is bridges the gap between the conceptual modeling and regulatory compliance, offers a lightweight and explainable alternative to the REST's BIM heavy system, and provides a regionally adaptable model for the low-BIM context beyond Bangladesh. I think the most powerful point of this project is it's a completely tool and project agnostic. So that means any kind of 3D modeling software that has some sort of Python framework can use it. And also any kind of code compliance or code can be implemented with this project. Probably just European building code or British building code can be adopted in this project. Thank you.